Good morning students. Today's topic is Hardy-Weinberg principle. Hardy-Weinberg principle. The Hardy-Weinberg principle says the allelic frequency in a population remains stable or constant from generation to generation. So Hardy-Weinberg he constructed an expression to explain the gene frequency in a population. According to him, according to this theory, the allele frequency in a population are stable and constant from generation to generation. The gene pool, that is total gene and their alleles in a population, remains constant. That is called the genetic equilibrium or Hardy-Weinberg equilibrium. The gene pool, what is gene pool? Total gene and their alleles in a population. Total genes and their alleles in a population remains constant generation after generation. The sum total of all the allelic frequency is equal to 1. Sum total of all the allelic frequency is equal to 1. For example, in a diploid P and Q are the frequencies of allele capital A and small a respectively. You see, you just remember this Mendelian monohybrid cross. The Mendelian monohybrid cross ratio is 1:2:1. You remember that, then it is easy to do this expression. The 1, it represents the dominant allele. The another one, that is it represents the recessive alleles, and 2 for the heterozygous alleles. So the same thing you remember, and then we can write it easily. That is instead of A, it is considered as a P. If it is P, 2 A's are there, so P squared. This is small a, it is taken as Q. Instead of 2 A's, it is written as a Q squared. Okay, how many two capital A and small a heterozygous genes are there? That's why it is taken as a 2PQ. Okay, you remember this, then it is easy to write this binomial expression. Sum total of all the alleles, allelic frequency is equal to 1. Example, in a diploid P and Q are the frequencies of alleles capital A and small a respectively. Example, in a diploid P and Q are the frequencies of alleles capital A and small a respectively. The frequency of capital A is equal to P squared. Probability of the alleles capital A with frequency P is the product of the probabilities, that is a P squared. Capital A, that's why it is a P squared. The frequency of small a is equal to Q squared. The frequency of capital A small a is equal to 2PQ. Capital A small a is equal to 2PQ. Hence, P squared plus 2PQ plus Q squared is equal to 1. P squared plus 2PQ plus Q squared is equal to 1. That is the binomial expression. P plus Q the whole squared. P plus Q the whole squared is equal to P squared plus 2PQ plus Q squared, that is equal to 1. This is the allelic frequency of a population. This allelic frequency of a population remains a constant. So hence P squared plus 2PQ plus Q squared is equal to 1. This is the binomial expression. Change of frequency of allele in a population causes a disturbance in genetic equilibrium due to evolution. It would change. When it would change? If any factors such as migration, genetic drift, mutation, genetic recombination, natural selection, these factors acting on this population, then it would change. The 1, that is genetic frequency, that is 1, it will alter when such a factors acting on it. This is examination point of view. This Hardy-Weinberg principle is very important.